Hello everybody, thank you for joining me today. Today we're going to be looking at the three main components of any electrical circuit: voltage, current and resistance. Now, some of our learning objectives include to define potential difference. So I'm going to give you the accepted definition that you must write for your GCSE exams, and to understand the link between potential difference, current and resistance. And I'm going to introduce three new equations to you. So this is a bit of a long video to recall and use the equation that voltage is equal to current multiplied by resistance. To recall and use the equation that voltage is also equal to energy transferred per unit charge, and to recall and use the equation that current is equal to charge per time. Now, if you're ready, let's get right into it. Okay, so now let's have a look at what we could argue is the three most important things about an electrical circuit. It's voltage, it's current, and it's resistance. The way I was taught this was through the hose pipe analogy. So say I have a hose here, and it's got water coming out of it. The pressure of the hose can be thought of as the voltage of the circuit of the pipe, right? If I increase the pressure, I get more water coming out faster, right? The water coming out has more energy. So if I increase the voltage of my circuit, I get more energy and so in an electric circuit, water doesn't flow, charge flows. So I get more energy per charge, more pressure, more voltage, more speed in the water, more energy per unit charge. So if I do this in symbols, it's V is equal to E over Q. Now, what are all the different units for all these? V is obviously just the same, voltage. Q is charge, which is C, which is in coulombs. So let's see, coulombs, which has the unit symbol C, and E is energy. Energy is always in joules for J. Joules J. So let's write here voltage V. Okay, so now we understand voltage in a electrical circuit. Now let's have a look at the size of the hose, right? This can be likened to the current. Now, if you remember from my last earlier on in the video, right? Current is the flow of charge, right? So current is charge a unit time. If I increase the width of the hose, more water can flow in the same amount of time. Same way, if I increase the current in a circuit, more charge can flow for the same unit time. So can you see how that links here? So if I do this symbolically as well, current, which has the symbol I, is equal to charge, which is again Q, over T. Now let's do all these units for all these. I is in amps, which is A. T is in is time, which is in seconds, and Q is again charge, which is in coulombs. C. Okay, so now are you starting to see how all of these tie together with the hose? Now, resistance. This is often the easiest one I find. Resistance. Now, if I have filled my hose pipe with, say, like random junk, like pebbles, gravel, all of this, the water has more difficulty in flowing out, right? It has to do more work against all the random stuff inside the pipe, which slows it down, right? So resistance is sort of ties in with the word, right? If you think about resistance, if you think about someone resisting you, they're sort of pushing you back. Okay, so you can think of resistance as a sort of pushback against current in a circuit. Now we can really define resistance as voltage, current. Again, sorry, let's write it all out. Voltage, wait, not I, voltage, current. And let's do all the symbols for this. V, I, and now resistance is actually something new. It's given the Greek letter O, omega, and it has the units ohms. Okay, so this is something new that you need to remember. Resistance has the Greek symbol omega for its unit. Unit symbol, and ohms for its unit. Okay, so now you understand the three main parts of an electric circuit. It's voltage, current, and resistance. Alright, so now let's tie these three things, voltage, current, and resistance, together in one simple equation. Now you can see here that this equation ends up being called Ohm's law, right, and have a defined bit here, but we're not going to define it just now. We're going to have a look at the equation first. So the equation is voltage is equal to current multiplied by resistance. If I do it with letters, V equals I times R. Now you could argue that this is literally the most important equation in all of electricity for your GCSE, and to be honest, you will see it time and time again. So when you understand that all these things are measured in different quantities, V, voltage, that's the same thing. Current, I, in amps, and resistance in ohms, omega. Okay, so what Ohm's law really boils down to is this. At a fixed resistance, so if I say fixed resistance, and this actually has a very special word, right, for a material that always has a fixed resistance, right? This is called an ohmic conductor. At a fixed resistance, the voltage will be proportional to the current, and that is Ohm's law right there. So positive voltage is proportional to current at a fixed resistance. Now, what does this mean? This means that if voltage were to increase in a circuit, the current would also increase, but this also has another form as well. I can also say that current is proportional to 1 over resistance. And how would I find that out? So if I did and this would be at a fixed voltage. So if I rearrange my equation here, V equals IR, V equals IR. If I want to take away R, so make I on its own, sorry, I will do V over R, sorry, V over I. Sorry, no, V over R is equal to I. So this boils down to at a fixed resistance, so I can cancel out R. 1 over resistance is directly proportional to I. So here, if I increase the current, I'll get a reduction in resistance. Now, these are very important concepts, so please pause the video and rewatch this section if you're unsure about anything, because you need to understand this for any sort of calculation you do in electricity, and especially the worded equations. Now, if you can do that, now you understand Ohm's law. Okay, so now let's have a look at this worked example now. As always, we're going to highlight all of our keywords. So a lamp of resistance 45 ohms is connected in series with a 9-volt cell and a switch. Draw the circuit diagram. So draw the circuit diagram and then calculate the current across the lamp. Okay, so let's do the first bit now. Let's draw the circuit diagram. So I know I have a lamp, which is that. The circuit diagram was that, and I have a 9-volt cell, which is like that, and then I also have a switch, which is like that. Cell, switch. Now, series, meaning that all these components are connected one after the other. So that's quite simple. Let's do that. So I have my cell here. Let's have my switch here. Let's have my lamp here. And that's it. That's our first circuit diagram done. So that would be around 2 marks. Now let's calculate the current across the lamp. Okay, we can do that. So I know that this is a 9-volt cell and the resistance of my lamp here is 45 ohms. Okay, so let's have a look at our most simple equation. V is equal to I R. I need the current across the lamp, which is I. So let's rearrange this for I. So V over R is equal to I. Okay, so now I know that because this is series, the current, and there's only one component here, the current is going to be 9 volts across, sorry, not the current, the voltage is going to be 9 volts across the lamp as well. So all I have to do is input my numbers. So I do, let's do it in green, 9 volts over 45, which ends up being 0.2 amps. So there I have the current across my lamp. 0.2. So that would be around 2 marks as well. If you could understand all this, well done. You're on your way to understanding all of your GCSE electricity. Okay, so now let's have a look at one of the harder examples. This is about as hard as it gets in your GCSE, so if you can get through this, you can get through anything, and I'm sure you can do this. So, as always, let's highlight all of our keywords. A 200 volt microwave transfers 25,000 joules to its internal circuits. Okay, calculate the charge that moves through the circuits. If the microwave completed the transfer in 5 seconds, what was the current that flowed during circuits? Okay, there's two things that we want to work out, charge and current. Let's try the first one. We know that we're looking at here potential difference and energy. If we go back to our potential difference definition, that is the amount of energy transferred per unit charge. So V is equal to E over Q. Now we want Q, charge. So let's rearrange this equation. So we end up with Q is equal to E over V. So now let's input our numbers now. So we get the energy transferred in joules is 25,000. The voltage is 200, and this ends up giving us 125 coulombs, because remember, that's the unit for charge. So that's 2 marks right there. Now let's have a look at the second bit. Microwave complete the transfer in 5 seconds. Okay, so we're talking about over time now. Current. What is current? Current is the flow of charge. Now, flow, when we're talking about a flow, we're always talking about over time. So we talk about Q over T. I equals Q over T. Now let's input our numbers into here. Our coulombs, we've already worked out our charge, 125, and our time is 5 seconds. So this just ends up being, right here, this ends up being, 25 amps. That's our answer for the current right there. It's another 2 marks right there. If you can understand all this, well done. You're going to do very well in your electricity portion of your GCSE.